The Food Service Exchange presents.
This video will demonstrate the proper way to perform a system diagnosis on Flaker ice maker units. Before we cover how to diagnose electrical and component failures, let's review the Flaker sequence of operation. The sequence of operation is controlled by a series of timers within the solid-state timer board. First, the Flaker begins a startup when the flush switch is set to the ice position and the power switch is set to the on position. Power is then supplied to the inlet water valve, allowing water to fill the reservoir. The unit will not begin the ice-making process until the reservoir is filled. Next, when the dual float switches indicate a full reservoir, the bin control takes over and allows the unit to sequence up. At this point, the gear motor and condenser fan start. Should the gear motor experience undue stress from the rotating auger or the pressure of ice extrusion, the machine will automatically shut down through the gear motor protect relay, saving wear on the gear motor and bearings. After 1 minute, the compressor starts. This delay allows any ice left in the evaporator cylinder to be removed before basic refrigeration begins. As the refrigeration system cools the water in the evaporator, ice begins to form on the cylinder walls within 2 to 3 minutes. The gear motor turns an auger inside the stainless steel cylinder. As ice forms on the inside wall, the auger breaks away the ice and moves it upward. The upward pressure extrudes the ice out the top of the cylinder and into the bin. Ice production will continue until the bin is full. Once the bin is full, the ice pushes against the bin control paddle. The paddle operates a magnetic proximity switch and the shutdown process begins. Within 6 seconds after the bin control indicates a full bin of ice, the gear motor, compressor, and fan stop. Self-contained units and DCM sequence down. 1 minute after the bin control opens and indicates a full bin of ice, the compressor stops. 1 minute later, the gear motor and fan stop. Before beginning the diagnostics on the Flaker ice maker, it's important that you first make sure there is proper water and power supplied to the unit. When troubleshooting for system failures, first, remove the covers of the unit. Place the flush switch to the ice-making position and turn the machine on. Remember, the unit will not start up unless the reservoir is full and both float switches are closed. If the water valve does not energize, check the water valve terminals for voltage. A meter reading of 24 volts indicates that the water control relay circuit is supplying power to the water valve. This means that the problem is either the water valve coil is open, the valve is stuck closed, or the water valve screen is plugged with debris. At this point, turn off the power supply and shut off the water supply. Remove the thumb nut and check for debris plugging the inlet screen. Next, check the coil for continuity with an ohm meter. Replace the water valve if it is defective. Some Flaker models have a built-in periodic flush. The flush valve is operated either by the manual flush switch or by the 12-hour flush timer. If no power is supplied to the water control circuit at startup, it could be off on the 12-hour timer. You can advance the timer or check the timer contacts with a voltmeter to determine if this is the case. After checking the flush timer, if there is no power to the inlet water valve, check the control transformer secondary to make sure control voltage is present. You can easily check the secondary and circuit fuse by removing the control box cover and checking across terminals 1 and 2 on the timer for 24 volts. If control voltage is present, check the flush ice switch for closed contacts. If the water valve is energized and the reservoir is overflowing, check both float switches and the water control relay. To check the float switch, twist and lift the assembly out of the reservoir. The float switch has 3 wires, black, red, and blue. First, check the blue and black or common wire with your meter at the control box connector. When you raise the bottom float, the switch should be closed. When it is down, the switch should be open. Now check the red and black wires. The float switch should again be closed when the top float is up and open when it is down. If the float switch needs to be cleaned, soak it in ice machine cleaner. If you take it apart, mark the top of the floats and be sure to replace them in their original position. This will allow you to have the correct timing on the water control relay circuit. To check the water control relay, review the wire color code on the wiring diagram and check the relay with your meter. When the reservoir fills and the water valve stops, the gear motor and condenser fan should start. If this does not occur, locate the bin control terminals on the timer board. Check the bin control's proximity switch by disconnecting the wires from these terminals. Check the wires with an ohm meter to assure that the bin control is closed. Another way to check the proximity switch is to use a jumper. If you jumper across the bin control circuit pins 5 and 6 and the machine starts up, the bin control proximity switch is your likely problem. The terminal numbers may vary on older models. Always verify the terminal numbers on the unit wiring diagram. The solid-state timer board controls the entire sequence of operation. To diagnose a bad timer board, first check across terminals 1 and 2. You should have 24 volts or the machine will not cycle up. Then jumper across terminals 3 and 4. If the machine starts up, you should check your water control relay circuit as previously discussed. If the machine still doesn't start, other circuits must be checked before condemning the timer board. Now, jumper across terminals 5 and 6 to check the bin control. If the unit cycles up with the jumper in place, the board is good and the problem is with the bin control circuit. Check your wiring diagram to determine which voltage should be present at terminal 8. Depending on the model you're working on, this terminal could either be a line voltage or a control voltage circuit. If your meter reads the proper voltage, then the timer board is good and is supplying power to the gear motor relay or circuit. If the gear motor relay is not energizing at this point, it may have a bad coil or a mechanical problem. If the condenser fan is running and the gear motor is not, the relay is operating properly and there may be a problem with the gear motor circuit. If the gear motor and fan start but the compressor does not, check the gear motor protect relay. To check this circuit, jumper across terminals 10 and 11. If the compressor starts up within 1 minute, the problem is in the gear motor protect relay. If the compressor doesn't start after jumping 10 and 11, check the compressor circuit. To perform a quick check of the compressor circuit, turn the power switch off. Place a jumper across the black compressor relay on the timer board. This will bypass the timer and allow the compressor to start. Turn the power back on. If the compressor runs, the compressor circuit is okay. If not, use basic diagnostic procedures to check the compressor and start components. If the compressor circuit is okay, the timer board is probably bad and will need to be replaced. Remember, when servicing any Hoshizaki ice maker, always refer to your Tech Specs guide for detailed information or call the Hoshizaki service hotline on your screen. Now that you have learned the various checkout procedures, you should be able to diagnose most problems that occur with the Flaker.